You know the first of these already. It's the one that you learned in C2. Sine squared x plus cos squared x equals 1. Okay, now what we're going to do is we're going to take that and we're going to divide everything by sine squared x. So sine squared x over sine squared x plus cos squared x over sine squared x equals 1 over sine squared x. So obviously we've got 1 plus, and here we've got cos x over sine x all squared equals 1 over sine x all squared. And you should know already now that cos over sine is 1 over tan, which is cot x, and that's being squared, and 1 over sine is cosec squared. So that's the second Pythagorean identity to learn. The first one you already know. Second one, 1 plus cot squared is cosec squared. Third one, you take your C2 equation again, and instead of dividing everything by sine squared, you divide everything by cos squared x plus cos squared x over cos squared x equals 1 over cos squared x. So that gives us sine x over cos x all squared plus 1 equals 1 over cos x all squared, which is sine over cos is tan squared x plus 1 equals sec squared x, and that's the third one. Tan squared plus 1 is sec squared. The first two compound angle formulae you're just going to learn, okay? And there is a video showing you a proof if you're interested. So they are sine a plus minus b, which is sine a cos b plus minus, so same sign as it was before, and then the other way around, sine b cos a. And then the second one is cos a plus minus b, and I just remember these by cos is cos cos. So cos is cos cos, cos cos. And also the signs change on this one, so it's upside down. And then because I've already had cos and cos, it's now sine and sine. And so that helps me to remember the sine one as well, because if cos is cos cos, then sine is the one where they're mixed up. Okay, tan. Tan a plus minus b is sine a plus minus b over cos a plus minus b, obviously. So we can use the formulas we already know from above. So sine is sine a cos b plus minus sine b cos a, and on the bottom cos is cos cos, cos a cos b, changing those signs upside down, minus plus sine a sine b. Now the clever bit. What you do is you divide everything by this thing that's in the bottom left, cos a cos b. So all four things, well, the top and the bottom, so therefore all four, get divided by cos a cos b. So what that gives us is sine a cos b over cos a cos b, that's them gone, plus minus sine b cos a over cos a cos b, and that's them gone, all over cos a cos b over cos a cos b. That's obviously just going to be 1 because it all cancels. And if you forget what to divide by, that's how you can remember. Just look in the bottom left and it's going to turn into a 1. And then minus plus, and then you've got sine a sine b over cos a cos b. Nothing cancelling there. I don't think I'm just gonna go over here because I don't think I can make a new page. So what have I got on the top here? Sine a over cos a, that's tan a, and then plus minus, and then here I've got sine b over cos b, so that's tan b, and on the bottom I've got my 1 that I knew about, and then my minus plus, and then I've got sine a over cos a times sine b over cos b, so that's tan a tan b. So these are your three compound angle formulae. Sine a plus minus b is sine a cos b plus minus sine b cos a. Cos a plus minus b is cos a cos b minus plus sine a sine b. Remember cos is cos cos. And tan a plus minus b is tan A plus minus tan B over 1 minus plus tan A tan B. So we're going to take the compound angle formulae and use them in a special way. Sine, instead of A plus B, I'm going to use A plus A. So that's sine 2A there, and this is equal to sine cos, so sine A cos A, and then plus, and then sine other way round, but in this case they're the same, so just sine A cos A, giving 2 sine A cos A. So sine 2A is equal to 2 sine A cos A. Cos 2A, well cos is cos, so that's cos A cos A, and then minus, because we're doing the opposite of what's in here, and this is a plus in here, so we're doing minus, and then sine. Oh, we're doing, sorry, sine A plus A, sine. So that can be written more nicely, cos squared A minus sine squared A. Now we get a couple of bonus ones here, that's why it's got plus 2 up there, because actually now I could replace the cos squared with 1 minus sine squared A. That would give me 1 minus 2 sine squared A, or I could replace the sine squared A with 1 minus cos squared A, and that would give me 2 cos squared A minus 1. So actually you get a couple of bonus ones there. You can have cos 2A is cos squared A minus sine squared A, or 1 minus 2 sine squared A, or 2 cos squared A minus 1. Sine 2A is just 2 sine A cos A. Last one, tan 2A, using the compound angle formulae, is tan A plus tan A over 1 minus tan A tan A. So I'm just literally using A and B as the same thing from the compound angle formulae, tan A plus A. So simplifying, 2 tan A over 1 minus tan squared A. The half angle formulae come from those 2 bonus ones that we got in the double angle formulae, which themselves came from the compound angle formulae. So the bonus ones we had, first of all we had cos 2A equals cos squared A minus sine squared A, but then we realised that we could change it to 1 minus 2 sine squared A, or we could have cos 2A as 2 cos squared A minus 1. And if you rearrange these two, you can have the half angle formulae, cos squared A is a half 1 plus cos 2A. You should be able to do that algebra, rearranging that. Or sine squared A is a half 1 minus cos 2A. So these are your half angle formulae. Sine squared A is a half 1 minus cos 2A. Cos squared A is a half 1 plus cos 2A. And we mostly use those in integrating. You do sometimes use them in trig, but mostly in integrating. So, a summary now. I'm going to go fast and hopefully you will be able to catch up. We've got 3 Pythagorean identities. Sine squared plus cos squared is 1. If we divide everything by sine squared, we get 1 plus cot squared is cosec squared. And if we divide everything instead by cos squared, then we get tan squared x plus 1 equals sec squared x. You do need to know the proofs. Compound angle, you don't need to know how to prove these two, sine and cos, but you do need to know what they are. So cos is cos, cos A, cos B. Turn that sign upside down, so it's minus plus sine A, sine B. And the other one is the one where they're different. Sine A, cos B, same thing, plus minus, and then swap them, sine B, cos A. Tan A plus minus B, you can prove, you put this one on the top and this one on the bottom, sine over cos, and then divide everything by what's in the bottom left, which will be cos A cos B, and when that simplifies it comes down to tan A plus minus tan B all over 1 minus plus tan A tan B. Then we can put A equals B in all of those. That's going to give us sine 2A is 2 sine A cos A. We're going to get cos 2A is cos squared A minus sine squared A, which is also 2 cos squared A minus 1, and it's also 1 minus 2 sine squared A. And tan 2A is 2 tan A over 1 minus tan squared A. 2 more, those little bonus ones which come from these two, you just rearrange it, that's all you have to do, and you get your half angle formulae. Cos squared A is a half 1 plus cos 2A, and sine squared A is a half 1 minus cos 2A. They're both cos 2A because they both came from this same equation, cos 2A equals. They were the bonus ones on the end.